I'm going to describe how to use an interactive simulation for a binary system where the liquid phases are only partially miscible, and so we have the possibility of 3 phases at some conditions, vapor and 2 liquids. The simulation, I'll just go through briefly what's involved, and then we'll look at the actual simulation, which is a browser-based simulation. So on the right side, we show the amount of each phase. So the alpha phase, the alpha liquid, that's a liquid that is enriched in component A. We're plotting the mole fraction component B on the x-axis. The beta phase liquid is a liquid that's enriched in component B. For this particular point on the phase diagram, these are the mole fractions of each of the 3 phases. And then the bars represent the amount of each of these phases. So the simulation allows us to change the overall mole fraction. It also allows us to add heat to the system. And what that does, of course, if for example down here we add heat, then we raise the temperature. When we're at 77 degrees centigrade, now adding heat doesn't raise the temperature until one of the liquid phases disappears. When that happens, and then we have just one liquid phase and vapor in equilibrium with it. So let's look at the interactive simulation. You can see if I change the mole fraction of B, I move the dot representing the overall mole fraction, and I change the relative amounts of the 2 liquid phases when we're in the 2 liquid phase region. If I add heat, I change the amounts. I also change the compositions and change the temperature until I get to the point where we have now 3 phases present. Now as I add heat, the amount of vapor increases, the amount of liquid mole fractions decrease. Now the system, I can reset back to my initial conditions. And let's look at adding heat from this starting point. We get to constant temperature region and we continue to make vapor until the beta liquid phase disappears. And now the temperature changes and we only have the alpha liquid phase and vapor in equilibrium. And if we continue that heat, we'll get into the region where we only have vapor. So the simulation has details on the calculations used to obtain the simulation. Also has directions basically corresponding to what I just described, and the idea here is to help understand this behavior when we have liquids that are only partially immiscible. How when we change the temperature, we change the number of phases, and there's only one temperature, namely about 77 degrees C, where we have 3 phases in equilibrium.